Hey guys, welcome back. Today we're going to do an introduction into electrochemistry and redox reactions. Hope you guys had a good break and are ready to get going again. Electrochemistry involves the transfer of electron in different types of chemical reactions. These are the most common types of chemical reactions. Anything from a battery to a combustion reaction, all are redox reactions where there's transfers of electrons. Let's go over the definitions of oxidation and reduction. So empirically, the definition of oxidation came from when a pure metal was oxidized. This could have been through combustion or corrosion, and it forms a metal compound, so there's actually a gain in mass. Now, theoretically, how this happens is that there must be a loss of electrons in the metal. The metal must go from a neutral metal atom to a metal ion. And we know from Science 10 that metals lose electrons to become positively charged. So the definition of oxidation is that there is a loss of electrons. And we get an acronym that will help us remember. LEO. LEO means loss of electrons is an oxidation half reaction. Similar to oxidation, the empirical definition for reduction comes from when a metal compound, or ore, is reduced to a smaller mass of pure metal. So the oxygen is removed from the compound, usually it's oxygen, to produce a smaller mass. So we have a reduction. But how this happens theoretically is there must be a gain of electrons. The metal ion, which has a positive charge, must have gained electrons to become a pure metal. So again, we get an acronym. Gain of electrons is reduction. From the first one, we have LEO, loss of electrons is oxidation. And from the second one, we have GR. So we get Leo the lion says GR. Something easy that when I was in chemistry 30, way back when, I still remember that acronym. This is a red ox, and we are going to talk about the half reactions for reduction and oxidation. For the simple reaction between chlorine gas and calcium metal, we can write the normal balanced chemical equation like how we learned in Science 10. This is already a balanced chemical equation, so now we can look at what's actually happening to each individual species. Let's look at the metal first. Calcium solid is in its elemental form and has a charge of 0. On the other side, the product side of my reaction, I have calcium and it's combined with chlorine, and so it's in an ionic compound form. So this must be the 2+ form of calcium. If calcium went from a charge of 0 to a charge of 2+, you have to figure out if it gained electrons or lost electrons. If you think it lost electrons, you would be correct. It has a charge of 0. In order to get a charge of 2+, it must have lost 2 electrons. So this would be a loss of electrons, and it would be the oxidation half reaction. Now, we need to figure out where those electrons go. If I put 2 electrons over here, that would be the calcium gaining 2 electrons, and then it should have a 2- charge. That would be incorrect. So I need to have the electrons on the product side, and this also shows that my charge is balanced. I have a 0 charge on the left, and with a 2+ and 2 electrons, I have a 0 charge on the right. Now let's look at the chlorine. Cl2 gas turns into 2 Cl1- ions. The overall charge with 2 1- ions is 2-. On the left, the overall charge is 0. Now, to go from 0 to 2-, what must have happened? Well, opposite to what happened before, the chlorine must be gaining electrons, gaining 2 electrons to become 2 Cl1-. Now, to show that, we have to show the electrons on the reactant side. Chlorine gas gains 2 electrons to produce Cl- ions. In all oxidation reduction half reactions, it's very important that we have the number of electrons being gained and lost that are the same. So if you had a scenario where the electrons being gained was different from the electrons being lost, we could remedy that by having coefficients in front of the entire half reaction. Take a look at this net ionic equation and try and write the two half reactions for this. Pause the video and take a minute to try, and then when you're ready, restart the video. Let's start with the copper ions. Cu2+ is turning into Cu solid. Now I leave space on both sides of my reaction so I can put the electrons where they need to be. Now we look and we say, okay, it's going from a 2+ charge to a 0 charge. In order for that to happen, it must be gaining 2 electrons. So gain of electrons is reduction. This would be the reduction half reaction. And in order to show gaining of electrons, I have to have them on the reactant side. Cu2+ plus 2 electrons makes Cu solid. And again, the charges balance. We have a 0 or a neutral charge with the 2+ copper and the 2 electrons on the left, and we have a neutral charge on the right with our copper metal. Let's take a look at the nickel. We start with nickel solid, and we are producing nickel 2+ aqueous. Now with this, we need to figure out what's happening with the electrons. So the charge over here is 0, the charge over there is 2+. To go from 0 to 2+, I must be losing electrons, and it must be oxidation. Now, how do I make the charges balance? I have to add 2 electrons to the right-hand side.